How's everybody doing? I'm about a minute early, but I'm just trying to get set up here. Looks like they're logged in, and I'll just wait for a couple more. Tim, I can see you, so if you're on and you can hear me and everything looks cool, send me a quick text confirming that AV is in good shape. I'm out here bravely doing this, I think, from the wilds of San Francisco. See if I could do a webinar broadcast from downtown, and so far so good. Anything could happen though, right? Like fire trucks will go by, or somebody will sit down and start having their lunch here at this table. But I think we'll have fun. I'm going to kind of just jump right in and probably not spend a lot of time introducing myself, but really just kind of get into the material. I've got some slides for you guys, so I'm going to try to screen share, and hopefully everything's good, So here we go. Just jumping right into the material. All right, I'm going to screen share my application window. Here we go. Okay, cool. So no nonsense estimates. Basically, what we're doing here, let me just turn off my notifications to keep it quiet here. All right, and good. We're going to talk about a way of estimating that is based on a lot of the work that I've done in and around Agile, Lean, and Kanban. So, I'm going to go through this pretty quick. And hopefully there'll be a little bit of time for questions at the end. But, we can always sort of talk more one-on-one after this if you have questions or you're curious about how you would apply this in your own environment. So let's start a little bit with, the general idea of sort of software development projects, right? So why is software hard? Why do we estimate in the first place, right? So we want to build software to solve business problems typically, and so let's think about sort of why software estimation is hard and why it's a difficult practice in general, right? So if you think about what software is doing, it's basically sort of automating manual processes in the information world, right? Like it's basically rules. And the unique thing about software that makes it so valuable is that once you've encapsulated one of these rules, once you've sort of captured and automated a particular business process, that's done, right? Like you should never have to rewrite that particular piece of algorithm again. You write it once, it's pretty much very inexpensive or free to copy and run in different places. But the process of actually capturing that manual work into code, that knowledge work is really where all the value is, right? So anything that you're doing in software development that isn't producing a novel algorithm around something that's never been automated before, everything else is pretty much waste, right? So folks building digital products have for a long time been focused on trying to reuse pieces that have been built before, right? So where the reusability comes in is that you've got software as a system of components. And so once you've sort of built a component, ideally you can reuse that component every place where it would fit for purpose, right? But really, software is about encapsulating and automating complexity, which makes it very difficult. The second thing that makes it hard is that the inventory in software, the work to be done, is invisible. So what I mean by that is if you are building physical products in a factory, what you see around the factory are parts, things that are partially completed work. And when there's a breakdown in the system, in the flow of building components and assembling them into the final product, it's very obvious in the factory because you have piles of parts in between stations and that sort of thing. But the thing is, in software development, there's also inventory, but it's all virtual, right? Like it's excuse me. So that means it's very hard to sort of track and see where your bottlenecks are, right? Like where things are breaking down the system. So you need a system to visualize all the work that you're doing, such as, Kanban board or some kind of project tracker. So if you think about project management software, the whole reason we use project management software in general is to track this invisible inventory so we can sort of see where things are. And I think those two things are mainly what contributes to the time it takes to build software. One is that the actual complexity of software is not getting any less. With every year, we're building more and more complex systems on top of things that are already built. So there's a lot to keep track of. And two, the process of actually assembling software as a team is very difficult because the inventory is invisible and we need a good system. And then finally, the thing is, we're not robots ourselves, right? So we've got humans in the mix, and a lot of the work required to develop products as a team involves communication between people, handoffs between people, differences in opinions about what should be done in what order or what's the right way to build a particular system. So humans are also a challenge. So we're going to look at how we can kind of leverage this existing landscape of software to do estimates in a way that doesn't have us at each other's throats and everybody losing sleep at night. So here are kind of the steps that I think make sense for how to do an estimation process without the dogma of any particular methodology, without any sort of voodoo or guesswork, but really just using what we have in front of us to build a process that works. So there's basically sort of 4 different steps. One is I see a lot of software teams, especially early stage startups, but also early stage teams within large organizations, sort of skipping the intentional planning of architecture, right? And so just because we're all thinking lean and we're all doing agile and we're sort of on the fly and on demand doesn't mean that we can skip thinking about sort of the hard technical questions of what we're building. It's still worth it to really plan your architecture and understand to make something work. Some of you are probably rolling your eyes because maybe you do a lot of this, and that's good. But I think there's a fair number out there that kind of skip that step of actually thinking through the specific component design of what we're going to build. And I'll come back to that in a second. The second thing is you really need to be tracking the overall throughput of your team. So in most cases, I mean, some of you, it may differ if you're an individual building a product all by yourself, but most of us are building software in teams and we have different functions. We're trading off different responsibilities. And so the overall process of producing software takes time. And so there's no, it's all about the cycle time of when you have an idea to when you've deployed that idea as a working feature. So tracking your cycle time is really important because it helps to establish a realistic sense of when you're actually going to get things done. The third piece is when you do sit down to estimate as a team, and you should do this really as a team with everyone who's going to contribute to building that piece of the product should be part of the conversation. What you want to do is estimate really in ranges of low and high estimates for each item. And I'll show you sort of what that looks like in a sec. And then look at the deltas between low and high and then go around, make some adjustments and go around again. And I'll get into detail on sort of how you do that in a sec, but I want to, specify that it's a range-based estimate, because software is a complex process and it's probabilistic, right? And then finally, number 4 is probably the most important of all, which is your estimates will frequently be wrong. And when they're wrong, that's an opportunity for learning and recalibration. So a lot of folks do estimates and then they don't double back to see how close they were after the work was done. So you're missing a really critical point of validation to say, oh, we thought this was going to be an easy feature. It turned out it was hard. Let's discover why it was hard so that the next time we see something coming along like that, it doesn't surprise us. So the team itself can get better at estimating, but only if you close that learning feedback loop. So to dive into some of the details in more specific, let's look at architecture again, right? So basically when I'm talking about architecture, what I mean is, you're building a system. You're building a product that's basically an information system, and systems are basically sets of components working together toward a common goal. And those components talk to each other using interfaces, right? So the interfaces provide a shared understanding between components about how they're going to work to do a job. And so everything about your system involves understanding sort of how many components and subcomponents are there in your system, how complex is each component, and how many connection points are there between those components. So when you sit down to do the work, whether it's building some kind of mobile interface or building some sort of back-end system or some sort of web component, there's always going to be a series of different interlocking parts that all go into doing the work of building that valuable feature for your customer. But that's just, step one, right? So understanding the code and interface complexity and understanding how reusable your system is, where are there pieces where you've already got part of the problem solved and you can leverage that, or do you have to do some refactoring to get good reusability? Those are all parts that go into the planning of the actual work. But remember, as we're going to talk about in a minute, it's not just the actual work of doing the software development itself. There's a human process that we're going to talk about in a sec that where a lot of the work is actually not actually coding. A lot of the time required to ship is not just coding. So, but you just cover this architecture thing. Once you sort of really understand your overall architecture and keeping in mind that there are also benefits and costs to leveraging third-party systems and components. That's sort of an unavoidable thing in today's world. You don't want to have to build everything from scratch. You might have payment systems, you might have storage systems, you might have all kinds of other systems that you're using that are pieces of your overall network. Those third-party components represent a risk and are can be unpredictable as well. So you have to include all of that just in your understanding of what is the work required to build such and such a feature. Once you understand that, it's time to kind of move on to the actual human process of building software, right? So this is where we're thinking of software as a team process. We're passing work from one person to another, or we're working on it together. And most of the time, frankly, from what we've seen in the industry, the total amount of time that a piece of functionality takes to get from an idea on a whiteboard to actual deployed software, a significant portion of that time is actually subcomponents in wait states between work steps, right? So you do some design work, there's some wireframes, they sit in a queue until it's time for someone to pick them up and implement them as code. That wait time is a big contributor to your work time, right? To your cycle time. So important to not just think about the work time itself, but to actually think about cycle time as a whole and to measure it, and to look for those bottlenecks where things are getting stuck, where people are kind of leaving stuff in a queue and then it sits for a while and then someone else comes along, right? And so you want to focus on overall throughput of the team rather than just being busy. So let's drill down into this just a sec. I want to show you guys sort of a way of thinking about this, right? So here's our sort of development board. A lot of us have, kind of boards like this, whether it's a physical board in your office or whether it's a digital board that you're using like Trello or Jira or something. These are states, right? Like each piece of work moves itself from the left side to the right side and goes through different states, from what's queued up, ready to do, to sort of being analyzed or developed or tested or and then deployed, right? So as your work moves through these states, you know, what we're trying to do is keep track of the time it takes to go across the board. So a visualization that I think a lot of people have access to and don't know it, or maybe don't really, maybe don't realize that it's there. I'm going to use sort of Jira as an example. Jira is not like my favorite tool, but they have lots of good charts, so I'll use it. Is this chart, which is called a control chart. So a control chart, basically what you have here is at the bottom axis is sort of each day as things get deployed to the end of the pipeline, they get a dot. And the dot, the vertical axis, is how long that piece took to get built, right? So this control chart, and this is an old chart. They used to use these, W. Edwards Deming, who was one of the sort of fathers of lean manufacturing way back in the 30s and 40s, used to use control charts for tracking quality metrics and that sort of thing. These control charts have been around for a long time, and they're very useful in being able to visualize an average and also standard deviations from the average, right? So what you have here is, as you're plotting your cycle time of features getting done, what it allows you to do is it allows you to identify the outliers, right? So these outliers, you got these small dots up here. That could very well have been a feature that was predicted to be easy to do. So its actual work time, if we were just using Scrum story points, for example, that could end up being a 3. You know, maybe it was very simple or whatever relative to other features. But for some reason, its cycle time was really, really long. It looks like it took 130 days to get this one done. I took this chart off the internet, but I've seen examples like this. Maybe that was stuck waiting for something from marketing, or we needed to get approval from legal. It doesn't matter. But the point is, the actual work time to build that feature may have not had anything to do with the actual time it takes to get it out the door and deploy it to a customer. So this is why it's absolutely critical, not just to understand the building time, what you can do as a team when you're actually coding, but think about the overall development process as a system and realize that there are these big contributors as well, right? Another way to sort of look at this is something called a cumulative flow diagram. This is basically the same graphic from a different, it's the same data, but with a different visualization system. So what we have here are each of the bands are basically those same columns in our board, right? So we've got our column here, whatever it is next, to do, doing, done, right? In the cumulative flow diagram chart, things get piled on top of each other, right? So you can see here's their little key in the corner with the colors of what how long items are sitting in, or how many items rather are sitting in each of those states over time. So each day you can sort of see a change in the number of items in each state, and that gives you a really good sense of the smooth or not flow of your items in your system. So in this one, you can see sort of regularized bumps across the whole system. My guess would be that correlates very strongly with their sprint cycle, right? So like things get loaded in and then things get loaded out in kind of this cadence. But anyway, these CFD charts can give you a lot of visualization into, how smooth your flow is and also where those bottlenecks are, right? So let's not forget about the process, not just building the software. So now let's talk about estimating and ranges. So the idea here is, once you as a team have a good understanding of your architecture, you have thought about each of the features and what it's going to take to build them architecturally, and you understand your overall workflow itself, where things get stuck, where there are dependencies either with third-party components or stakeholders in the organization that aren't directly in the development team, or even just folks on the development team that get tied up in one thing and can't help do another. Understanding your overall throughput, you could start to make estimates on these deliverables. And the way that I found, I learned this from a buddy of mine who I reference in the article, who may still be watching at this moment. this is sort of a snapshot of a spreadsheet that we would use. Here, I'll zoom out a little bit so you can see this. Okay, so the idea here is that when I put these stories in, they were in chronological order, story 1 through, looks like, story 12, right? Don't worry too much about the epics. This would just be sort of a labeling. If you wanted to cluster stories into particular epics, you could sort of see how they group. But basically, the stories here were originally put in an order. And then what we did is, story by story, we as a team would give a low estimate and a high estimate for how long we thought it would take us to do those stories, right? And then this last column here, the delta, is basically the difference between those two numbers, right? So after we went through all the stories, what we would do is actually resort the whole list by the biggest delta at the top. Now, why do we do that? The reason we do it is because to see that a story has a low estimate that's very low and a high estimate that's very high means we don't really have the slightest idea what's going on there, and we need to talk about it more. That big delta represents an enormous amount of uncertainty in terms of what's really involved in this story. So by sorting the list by the biggest delta, what we're doing is we're surfacing the story that we know the least about. And we can have further discussion about, well, why do we think it could be anywhere from 16 hours to 32 hours? That's a big difference. Let's talk about why it's 100% difference between the high and low estimate. And then the team can drill down into the architecture and drill down into the process to try to discover, well, maybe there are some things we can surface here. And we would redo the estimates after that discussion. Maybe you focus on just the top half of the list and try to get those low and high estimates tighter based on further discussion and further investigation. And then you readjust the list again. You resort it based on the delta once you've squeezed those deltas. And then perhaps a different story will bubble up to the top. And after you do this 2 or 3 times as a group, what ends up happening is by the end of the session, you've hopefully tighten the low and high estimate bands so that the deltas are very small, right? So you're kind of forcing yourself to prioritize the discussion around the stories that we have the least amount of information, as indicated by a huge delta in low and high, and iterated on that several times. You can do this within an hour or 2. This isn't like a huge long process. It just forces the attention team on those stories with the widest delta, right? So then we've got our estimates, closer in ranges. And then the next thing to do is we go through the work and then we look back at our control chart. And at the end of the sprint or the end of the iteration, when it's time to do estimates again for the next set of stuff, we first look back at the stuff we estimated last time that's done, and we see what the actual times are. Why do we do this? Because we need to calibrate the team, right? So we need to basically build an internalized understanding on the team of what estimates really mean in our process. And that's going to take several iterations, several sprints to start to build an understanding of the team. So when we've surfaced, we had estimated last week that this would take 16 hours. It looks like it took 45. We do an investigation and we see, okay, well, that's because we got stuck at this wait state because there was an unexpected refactoring of the such and such system, or we didn't realize that this required approval from legal, so we had to wait for them, and next time we should call them earlier in the process to make sure we get those approvals. That sort of thing. You can begin to identify patterns of where things get stuck so that the next time you do your range-based estimates, the team generally has a better understanding of what the real impact of architecture and the real impact of process is on their estimates. And the team will get better at estimating over time. Right? So that's generally the overview. I'd like to believe this is one of the fastest webinars we've ever done. It's about 22 minutes, which I think is a record for me. I'll leave you this little quote, and then I'll jump back over to the interface to see if there are any questions in the chat, and I can answer them. But remember, you don't have to change. Survival is not mandatory, as told to us by Deming, kind of the father of change management. So let me kill my sharing screen, and we can engage some questions if there are any. And if not, nobody has any questions, if you haven't popped anything in the question interface or in the chat, I will bid you good day. And Feel free to reach out to me after the fact if there are questions. This is being recorded, so if you're watching the recording after the event, you can reach me very easily at startuppatterns.com. There's information there for you to schedule a 30-minute session. I encourage everyone on this webinar to reach out and book a 30-minute session with me, and we'll chat about how particularly you're getting stuck in estimation, and I'll see if I can help you. In any event, thanks everyone for coming, and I'll see you at the next one. All right, take care.